So I first just wanted to apologize for the delay. We had some technical issues, which I've never had at the beginning of a talk before. So that's awesome. It certainly prepares you. Okay, so a little bit about myself. I run PyLadies DC with Katie Cunningham in DC. I have lots of dogs, and I'm a PhD student in computational social science as of 2 days ago. Thank you. And I do lots of work on my house. I've been fixing windows for almost a year now. Okay, disclaimer. So I'm going to sort of be drawing some analogies today, talking about some people, talking about some Python packages, and what I'm going to say is these are my own opinions. They don't represent my employer. They don't represent anyone. And they also don't represent Cheese Shop, which I'm taking some of their data from the Python packaging index. It's just me and my fiance. So enough about me. Let's talk about us. So we're going to have two parts. The first part is going to be a lesson in sociology and social complexity. The second part is going to be looking at PyPy as a case study of distributed governance. So first, some definitions. A polity. A polity is a social system consisting of society of members and a system of governance for managing public issues with policies and for solving issues already affecting a society. So first example, just to illustrate this on how we can apply this to technology, GitHub. So GitHub itself is the social system. The society of members are the GitHub users. The system of governance is defined by the software itself, that is GitHub, the UI. And it's used, GitHub was, part of its role is to manage public issues, i.e. solve barriers in collaboration that you might have with like SVN. On a more micro level, a repo. So looking at a repo on GitHub, that's your social system. Society and members are watchers, forkers, contributors, managers. The system of governance is defined by managers and committers. And lastly, managing public issues. I don't think I need to draw that too far. Solving bugs and the workflow. So, the other day I had a conversation with Guido, and one of the things he had said to me was one of the goals of software development is to make it so people can help themselves. And that's what's happening, distributed governance. So that's awesome, and I know you guys really want to hear more. So the title of this talk was Python Tribe, had the words Python Tribe in it. Let's go ahead and define that. So here's an ordinal typology of political systems. Starts with tribe at the bottom, goes to chiefdom, state, and empire, each of them having their own requirements. So a tribe is defined by kin networks, polity that shows the first institutions. Chiefdom has a paramount leader, no specified institutions. A state has specialized institutions, and an empire is multicultural. So are we a tribe? Well, I want to say, I'll argue today that we're more state-like than tribe-like. When I submitted this talk, I used a tribe because I think it was a better word. So, we're going to look at sort of our measurement by looking at sociogenesis, a measurement of social complexity, on where we are on that tribe, chiefdom, state, empire scale. So social complexity is an attribute of a polity that defines the scope and depth of its institutional organization and is measured by the ordinal scale that we had just discussed. So let's go back, way back to high school. And talk about Mesopotamia, the Andes, Mesoamerica, and East Asia. These are the earliest earliest tribes that had reached statehood. In the beginning, there was lots of wars. This is Mesopotamia. And over time, this is East China. Old groups fall out of power, new groups come in. Now let's look at a more familiar timeline. I don't know if you've ever seen this, but it's a timeline of programming languages. And so I'm proposing the emergence of complexity within programming languages, making Fortran, Lisp, APL, and Snowball the earliest states. As you go look at that timeline, and I recommend you look at online because you get a totally different experience, and you hit the 1980s, you get a big period of transition and development where languages merge and split apart. In 1991, Python was added, and now in the present, you don't see that sort of, let's call it a disruption of languages coming and going into each other anymore. It's kind of like this autonomy of city-states. A little like, let's say, North America and Europe today. People respect each other's boundaries. So how does social complexity relate to programming? Let's go back to that idea of governance, issues, and society, the elements of a polity. So there's issues within the polity, and those issues affect society. Society influences governance, and the governance takes care of the issues. Now let's go back to those earlier examples, Github and a Python library or Python repo. When you have the governance, you have an issue, they come in, they take care of it, and that is coming from the society that usually that's filing those issues. Okay, I think this is the last definition, collective action. Interpersonal coordinated behavior to achieve a common goal. Collective action puts you in a realm of politics. It also produces public goods. Issue resolution has to have a collective effect or public effect. So if we look at issues, when managed, the stress goes down, right? When you use a repo or you interact with a piece of software, you have a lot of issues. You don't want to use it. It's difficult. It becomes stressful. The governance manages those issues. And if the issue is too big, well, then the system doesn't survive. So now, something a little bit more concrete, which you guys know, PyPy, Python Packaging Index. So instead of comparing this as so much of a polity, it's more of an institution that is an artifact of the polity. So PyPy is my argument for why Python should be considered more of a state rather than a tribe. Because the minimal thing needed for a state was specialized institutions. So you can get the data from PyPy, everything you ever wanted, through PyPy's XML RPC. And you can grab package lists, releases, package roles, package downloads, whatever you want. To my knowledge, I have not seen a limit to their API, but I wasn't really trying to find the limit. There are 29,000 packages, so it's not like a huge amount of data. But some interesting things to point out are it's up about 4,000 in the last 6 months, because I had grabbed a data set when I first started this 6 months ago. There are about 10,539 owners and managers, and the number of collaborators is now 9,098 and is up approximately 2,000 in the last 6 months. And by collaborators, I mean people collaborating on multiple projects. So the top 10 downloads. Now, as you look through this list, you should note, Nose has 2 different versions in this. So if you add those up, it gets bumped up the list. Also, for some reason, Setup Tools is split up with the same version, but it was in 2 different records. I did not go back and find out why that was. I noticed that after the fact. But obviously then setup tools would be first, I think paste would be second, and nose would be third. Download distribution of packages. So looking at the packages, each package has a certain amount of downloads, and that's a power law distribution. The scale is log, so that means that a lot of packages have little to none downloads, and then a couple, like these guys, have a lot. They're the ones on the right side of the scale. So issues with the data. One of the things I noticed while dealing with it was that it seemed in some cases some people were kind of making up their own definitions for some of it. It seemed like there were standards out there, but in particular, one of the fields I found interesting was the download URLs. Download URLs had all sorts of things in the field value, including different types between string and, they had strings and they even had none types. And the unknown's actually not a none type, but it's a string that says unknown. So top 10 homepage URLs. So looking at download URLs, that didn't seem to be the right thing to be looking at. So I looked at homepage URLs to see where people are storing their code. And top one is Github. Going beyond that, .python.org, Bitbucket, so on and so forth. Now, interesting to note, besides the amount difference of how much is on GitHub, is that GitHub repos went up approximately 3,000 in the last 6 months, which means that a lot of the either new ones that came on or transitions was approximately all of the extra additions of packages. So now let's talk a little bit about how people collaborate between packages. I'm going to show you some network analysis stuff, and I'm going to show you how people collaborate between packages. So people are going to be nodes, and the link between them is a package. If they work on a package together, they get a link. So what I used was Network X for this, and Network X, I pass the package and the username, and it kind of folds over on top of the package. So the network, that's the whole network. I mean, it's kind of useless, but to see a picture of the whole network, but it's nice. I think it's kind of light, but you can see at a closer picture that there are some sort of little groups off on the edges without doing any pre-trimming, where there are these isolated islands of communities. And normally to get some of that, you have to massage the network a little bit. So now the core. The core, deeper in that, and I'll show you that in a second, is a lot of ZOP and a little bit of Plum. And the reason for that is that a lot of ZOP has, a lot of the ZOP packages have a lot of organizers and or owners and managers attached to them as opposed to other packages. I think they're in the 37 is the highest, so, and then so on and so forth. But a good chunk of them are in the 30s, and they're all ZOP. I don't know why this is. I assume that it's because ZOP's been around for a long time. This is actually something I wanted to look in further to see if that's how effective that is or how that dynamic works in comparison to other projects that only have 1 or 2 or 5, and see how those sort of dynamics between the groups are. So that's more of like a more focused view of the ZOP core. Now, looking at other qualities, there are other things you can look at sort of in the social network, boundary spanners, bridges, triads, like I said, 3 people working together, dyads 2, and you get a lot of those on just one-off projects. So one person I found was David Burns, who I reached out to right before this talk, just to give him a heads up. And he's a community bridge. I think he's a Selenium developer, And so he acts as a bridge between sort of those two communities. He's the dot in the middle. I don't know how well you can see it, but he's the dot in the middle, and the two communities are on the top right and the bottom left. So there was a lot more we could do with this, but I felt like the idea of polities and the idea of governance was going to be sort of a lot to chew on. And some of these next steps I already have pocketed, but I didn't include today. And that is predictive modeling on package growth rates, on topic area growth rates, time series analysis on releases to see sort of how effective a group is when they release, topic area analysis and collaboration, and last but not least, GitHub contributions, tickets, commits, and changes to the wiki. Now, I wanted to speak a few minutes about GitHub to measure community. GitHub has an API, and you can grab the data from the API. And one of the things I had done when I started this was I started to pull down information for Python-specific packages. And then I ran into a big problem really quickly, and that was, how do I measure community? What is a contribution? So how do I measure one commit over another and say that that is a more valuable contribution? Or is that even possible? Are all commits are equal? And what is the value of somebody who participates as somebody who submits issues or contributes to the wiki or in some other way? So I was actually hoping for your help on this, in giving me ideas, because I'd like to move farther and look at how people are actually working together and collaborating specifically on Python packages. And I'm not necessarily partial to GitHub, other than they have the nice API. The rate at which we as a community are using them is going up. So obviously that's going to probably miss like huge sects of the community that aren't on GitHub because they have some specialized place they store their repos. It is what it is, but still it'll give us some sort of information on how people are interacting with each other. And that's it.
Thank you. So we have about 6 minutes for questions if you want to work your way to the microphone here so everyone can hear you.
Hello. Hey, that was really great, so thanks a lot.
Thanks.
I'm really obsessed with political and market research data these days, and I was wondering why limit yourself to Python. A concept that had been introduced to me this past year was normative data, which is the normal thing you'd expect for a community. I'd like to see these graphs for Python versus Ruby and understand the strength of our community as opposed to theirs, as opposed to the COBOL community that might be out there on GitHub that I don't know about, whatever it is. Have you considered normative data sets and comparing beyond just Python?
Yes, and I have considered that. I just haven't explored the other communities because there was so much to sort of create a baseline. I see this kind of like as an ongoing sort of story that keeps on going, in that with every piece, it kind of gets a little further into it. It's a lot to sort of take on in one talk and just do it all. And also, like I said, I edited a lot out of it just to keep it clean and to focus. But yes, I had thought of comparative statistics, and I had been looking at the Python stuff and sort of figuring out where to go with that. And I haven't actively searched for the sort of other ways of getting data for other programming languages, but I'm going in that direction. One last thing is I've also thought of, part of this was inspired by the idea of self-preservation, right? So if you see a community start to break apart or go downhill, and you see other communities are being more successful, do you want to stay on the sinking ship, or do you want to, jump ship? You need to have a job, you need to pay your bills. So that was part of this, to see kind of like how to try to identify like when programming languages are, you know, going downhill. We're not going downhill. Obviously, we know that. So.
I just want to let you know about a tool that you might not know about. A friend of mine created Mr.Cabot, Mr.Cabot, for looking at contributions within the Plone community. But it's also intended to be general purpose enough that you could analyze other communities as well. And it looks at Github and Stack Overflow and mailing lists. And I can't remember if there's another source of data. And then he has it trying to actually geolocate where those contributions are coming from and spit out a map at the end. So you might want to take a look at it.
Oh, wow, yeah, that's great. Thank you for the suggestion.
Okay, do we have any more questions? One more? I think we have time for one more.
Hi, thanks for giving this talk. I really enjoyed it. I was thinking about your slide where you showed the entire network, and you mentioned that that's kind of information overload. How much understanding can a reader really derive from looking at that map? Can you talk about what other forms of data representation you think are more useful for communicating? Like the bar graph with the power law scale is helpful, but what else do you, like what other representations would you want to use?
Sure. I mean, the network is not necessarily information overload in that you can look, when you look at sort of individual pieces of the network, you get more information. But it's just a network overview that is kind of overwhelming at points. The only thing you could get from the network overview I had was the fact that there was already these clusters that were on the outside of the middle, and you didn't have to do any massaging of the data to get those. They were just, yes, they're a part of the data set, but they're not connected to anyone else. So, I mean, are you familiar with the D3 libraries?
Yeah, somewhat.
Okay, so I mean, they have some great visual sort of ways of demonstrating the data. You kind of have to figure out for whatever data set you have.
Okay, thanks.
Okay, let's give Jackie another round of applause. Thank you so much. And if you have any more questions from her, I'm sure you can come and ask her afterwards. Thank you.